Everyone, welcome to DCS 5058 operating system. In this video, I will be talking about deadlock and what are the necessary conditions for deadlock. Basically, what is deadlock? Deadlock are a set of block processes each holding a resource and waiting to acquire a resource held by another process. For example, in the below image, as you can see, we have two processes, T1 and T0. And two resources, resource 1 and resource 2. T0 thread has a lock on resource 1 but requires resource 2 for finishing execution. It's the same as process T1 that has a lock on resource 2 but requires resource 1 for finishing execution. To simplify how the deadlock works, this is an example how the deadlock might happen but with a real life situation. As you can see, the cop already has the criminal friend as a hostage and will release unless the criminal releases the hostage, while the criminal also won't release the hostage unless the cop releases his friend. This is also another example of deadlock that might happen in your computer. Now, what are the conditions for deadlock and how to avoid the deadlock? The first one is circular wait. Circular wait is a closed chain of process exists such that each process holds at least one resource that needed by the next process in the chain. The next one is mutual exclusion, which is only one process may use a resource at one time. The third one is no preemption, which is no resource can be forcibly removed from a process holding it. And the last one is hold and wait. Process may hold allocated resource while awaiting assignment of others. For example of circular wait, what we have here is two processes P1 and P2 and two resources R1 and R2. The process P2 already acquired resource R1 and is waiting R2 to complete execute. But the resource R2 already acquired by P1 and is waiting for R1 to complete execute. Next is how do you handle deadlock. The first one is preemption. The second one is kill one or more processes. The third one is rollback. For the next part, I will describe about the deadlock Banker's algorithm. There are two types of state that will occur during the Banker's algorithm. The first one is safe state. Safe state is when a process requests an available resource, system must decide if immediate allocation leaves the system in a safe state. System is in safe state if there exists a safe sequence of all processes. The second state is a unsafe state. The figure shows is an unsafe state is deadlock free if there is a sequence of processes. For example, P1 until Pn, a deadlock free sequence such that P1 might finish if there are enough unallocated resources to satisfy its current outstanding request, but not necessarily its entire claim. In general, Pi might finish if Pi-1 does. The state is deadlock free since no process is waiting. However, it may be unsafe because the process may now request resources that put them in a deadlock state, no matter what action the allocator takes. What we have here is a sample question of a Banker's algorithm. In a Banker's algorithm, what you will get is allocation matrix and a max matrix for each of the process, which is process 1 until the process 4. You will also be providing with a available matrix. Our purpose is to find whether if the process is in a safe state or an unsafe state.
Okay, now we do the solution for the question. So, first step, did the instance. The formula is allocation plus available. Okay, so this is the answer. Okay, now I will show you how to do this answer. Okay, so you just remember the formula, allocation plus available. Okay, you take a look from this allocation, 1 plus 4 plus 0 plus 0 plus 8, 5 and become 13. So the answer for instance R1 is 13. For R2, 0 plus 3 plus 3 plus 3 become 9. And for R3, 1 plus 4 plus 4 plus 4 become 15. This is how you do the instant. Okay, after this instant, the second step is need. The formula is max minus allocation. Okay, this is the answer. Okay, to do it, max minus allocation. For R1 and P1, 1 plus 1 minus 1 becomes 0, and 4 minus 4 becomes 0 also. 1 minus 0 becomes 0, 2 minus 0 becomes 0. They become 2. Sorry for that. Okay, we proceed to R2. P1 0 0 for 1. Okay, R2, P1 0 minus 0 becomes 0. For P2, 3 minus 3 also 0. P3, 7 minus 3 become 4. And 1 minus 0 become 1. To proceed to R3, P1, 1 minus 1, 8 minus 1 becomes 7. 1 minus 0 becomes 0. 6 minus 4 become 2. 7 minus 4 become 3. Okay, that's how you do the needs. Okay, third step is safety algorithm. Okay, the formula is need less or equal available. Okay, this is need, this is available, and execute or become true or false. Okay, needs. Need is 007, and the available from the question is 836. Okay, go through it. So 836 can execute, so become true. And the P2001, so 836 execute to 001 is also true. And P3142 for needs. So 836, you see that this is a bigger number, this is the less number, so it cannot execute, so become false. And P4 213, yeah, same, this need 213 is available, so 836 can execute to 213, so it's true. So it's only one false here, so it's safe. So we do the update availability. Okay, P1 allocation, this is from allocation 101 plus the available become this. So to differentiate it, 001 is need 001, and 947 can execute to P2, so it's true. Okay, now we do the second update availability is P2 allocation 430, allocation 430, and add the from this one and become 1377, and to reverse it to P3 142 is need 142, and then 1377 can execute to 142, so it's true. Okay, we proceed to the next update availability to P3 allocation is 034. Add 1377 become 13 10 11. Okay, P4 need 213 and 13 10 11 is available, the availability, the update availability. So 13 10 11 can execute to 1 2 3, so it's true. So the conclusion of this question is system is in safe sequence, safe state, sorry. So the safe sequence is P1, P2, P4, P3.
Okay, now this is the question 2. See, we have A, B, C, P1, P2, P3, P4, availability, mass allocation. Okay, this is the question. Okay, now I want to show you the solution for this question. Okay, firstly, we do the instant. We create the instant and the formula is allocation plus available. Okay, now I want to show you how to get how to get the answer. Okay, remember allocation plus available. Okay, to get 14 here is just follow the formula, just allocation add availability. So allocation for A 0 plus 3 plus 5 plus 5 plus 1 become 14, and proceed to B. Allocation for B is 1 plus 2 plus 7 plus 0 plus 2 become 12. How about C? C allocation 2 plus 3 is 5. Okay, that's how you do the instant. Okay, the second step we create the needs. The formula is mat minus allocation. Okay, max minus allocation for A, P1. A, P1. 0 minus 0 is 0. 7 minus 3 is 4 for P2. P3 6 minus 5 is 1. This is also 1. Okay, plus to B. 1 minus 1, 0. 4 minus 2, 2. 8 minus 7, 1. 1 minus 0 is 1. Okay. Proceed to C. 1 minus 0, 1, also 1, 8, 3. See, that's how you create the needs. Okay. Secondly, next we do the safety algorithm. The formula is need less than or equal available. Okay, this is need. How to get this? This need from here P1001. See, this available from the question 1, 2, 3. Okay, P2 for needs. Sorry, there's something wrong here. Okay, for needs fall. Okay, now to show you how to get true or false. Okay, firstly 1, 2, 3 it can execute to 0, 0, 1. Yes, because this small number, this is a big number, so it's true. How about this one? 1, 2, 3 can execute to 4, 2, 1. No. Why? This big number, this small number, so it can execute, so fall. Okay, about this one, 1, 2, 3 is can execute to 1, 1, 8. No, because 8 is big number and it's just 3, so can execute, so it's fall. How about this one? 1, 2, 3 it can execute to 1, 1, 3. Yes, because this big number, not big than this one, so it's true. Okay, that's how you do the safety algorithm. Okay, next we do the update availability. Okay, P1 allocation 0, 1, 0. This from allocation 0, 1, 0. I think it's from needs 0, 1, 0. Oh yeah, this for allocation because it's allocation from 0, 1, 0 plus 1, 2, 3 become 1, 3, 3. Okay, this is the update for availability. So the question is update. The solution is update availability. This is update availability. Okay, proceed to P2 to differentiate it. Okay, 4 to 1, 3, 3 can execute to 4 to 1. No, bit 4 is big number, so cannot fall. So 1, 3, 3 can execute to 1, 1, 8. Also fall because it's big number, so fall. How about P4? 1, 2, 3 can execute to 1, 1, 3. Yes, true. Okay, we update availability for P4. allocation 502 from allocation 502 from the allocation. Okay, just plus 133 becomes seed 35. Seed 35. This is the update availability. So want to differentiate is P2 521 less or equal to 635. So 635 can execute to 521. Yes, because it's bit number, so it's true. Okay, now we do the last update availability. P2 allocation 320 is from allocation. This is from the update availability. Just plus this one become 955 update availability. Okay, now 955 can execute to 118. No, because 8 is bit number, this is 5, so false. So the solution for this question is unsafe because no safe sequence and may lead to deadlock. Okay, that's it. Thank you for watching this video. If you don't understand or you want to ask something, just put in the comment. I will